Okay, welcome everyone. This is section 4.4 on laws or rules of logarithms. So your essential questions for today are: what are the laws or rules of logarithms? How do I use these laws to solve problems? So we're basically solving problems algebraically, and we're going to use that rule, that Tarzan and Jane rule, to work these logarithms. Okay, so here are the laws of the rules, essentially, of logs. Okay, so when you have law number one here, when you have log base A of A times B, that times can be split up where you have two log functions you can add those two log functions. So essentially, if I give you guys an example, let's say we had log base 2 of 4x, right? It's 4 times x. So I can expand this and say this is log base 2 of 4 plus log base 2 of x, right? I can split that multiplication up into 4 and x with the log base 2. Okay, that's rule number one. Rule number two is when we are dividing. Okay, it's going to be log base A of the numerator minus log base A of the denominator. So for example, if I have log base 3 of x over 27, that can be broken down into log base 3 of x minus log base 3 of 27. All right. And then the last one, log base A of A to the C power. Whenever you have an exponent, that can come down and be multiplied to whatever the log base A of A is, right? So then if I give you guys an example, let's say it's 8 to the third power. This can be 3 times log base 2 of 8. Okay? And here, in all of these rules, we can either expand them like this, or we could go from right to left. We can condense them. Okay, they're both equal to each other. So if I see something like this, and I need to condense it into one, I can put it back into this. Okay, so that's what we're gonna do. And the rest of the video, of the rest of the class, is just going to be examples on using these guys and using the Tarzan and Jane rule, okay, of logarithms. Okay. So here is our first example. What is the value of log base 2 of 4? So if I rewrite this as log base 2 of 4 and I make that equal to x, then I can just solve for x, right? If I solve for x, I solve for log base 2 of 4 because I set it up where x equals log base 2 of 4. So if the log function is by itself, right? It's isolated by itself. Then I'm going to take the base. I'm going to do the Tarzan and Jane rule. So 2 is my base. That's my Tarzan. X is my Jane. So it's to the x power equals 4. Okay? So you have to think 2 to the what power equals 4? 2, right? Equals 4. So 2 to the x power equals 2 to the second power. So x must equal 2 because we have the same base. Okay, once we have the same base, the exponents need to be the same as well if they're equal to each other. All right? So just think about it like that. And moving on to the next one, log base 3 of 81. Again, I'm going to make it equal to x. Use the Tarzan and Jane rule. 3 is my Tarzan to the x power equals 81. I know that 3 to the 4th power equals 81, right? 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So those are 4 3s. So 3 to the x power equals 3 to the 4th power. So x must equal 4. Okay? Those guys are pretty easy. What if we have something like this? So this one, we have log of the 5th root of 1,000. The first thing you have to remember is if it's just log, right? There's an invisible 10 that's there, okay? So the 5th root of 1,000, again, I'm gonna make it equal to x, and then I'm gonna get the 10, because that's my Tarzan, to the x power equals, I'm gonna make this 1,000 to the 1/5 power. Okay, which is the same thing as 5th root of 1,000, right? So now I need the same base. So I look at 1,000 and I need a base of 10. So 1,000 is 10 to the 3rd, right? 10 to the 3rd power to the 1/5 power equals 10 to the x power. Now, when there's a power to a power, the 3 to the 1/5 power, right? Power of 3, power to the 1/5 power. What do we do to simplify this? Multiply, right? We multiply this, so it's 10 to the x power equals 10 to the 3 times 1/5 power, which is 3 over 5. Okay? So then if 10 to the x power equals 10 to the 3/5 power, x must equal 3 over 5. All right, and that's my answer there. Okay. What is this one? That one looks kind of funky because it's to the 32nd or base of 32. Again, I make it equal to x. So I'm going to use the Tarzan and Jane rule. 32 to the x power equals 8. Now I need the same base. I need a common base. Okay. Between 32 and 8, what is my common base? Those are the questions you have to ask yourself. Most people say either 8, 4, or 2. Okay, you got one of those 3 numbers you guys are thinking right now. 8 squared is 64, which is not 32. Okay. 4 squared is 16, which I cannot make 8, right? You can think about it as a fractional exponent as well, but that's extra thinking that you don't have to do. Okay, so just try and find a number that'll make both 8 and 32. So it has to be 2, right? Because I gave you guys 8, 4, and 2. So 2 to the 5th power equals 32. So if that to the x power, so here we know 2 to the 5th power equals 32. Okay. And then that equals 8, which is 2 to the third power. Okay. So again, when it's a power to a power, 5 to the x power, we're going to multiply the powers and get 5x equals 2 to the third. Now that I have the same base of 2, I can say 5x equals 3, divide by 5, divide by 5, x equals 3 over 5. Okay? All right. Next one. Now, in this case, we cannot use the Tarzan and Jane because the log function is not isolated. We have this 1 and we have this 4 that we can move to the other side. Okay, so I'm going to move the 1 first by adding 1 to both sides. So that's 4 ln of 6x plus 1 equals negative 12. Okay. And then I'm going to divide by 4 to get rid of or to move that 4 to the other side. So that's ln of 6x plus 1 equals negative 3, right? Okay, so I have ln of 6x plus 1 equals negative 3. ln of 6x plus 1 equals negative 3. Now, you know that ln is just log base e, right? So I'm going to substitute log base e for ln of 6x plus 1 equals negative 3. Take now that my logarithmic function is isolated, I can use the Tarzan and Jane rule. E to the negative 3 equals 6x plus 1. Okay. Now I want positive exponents. Okay, that negative 3 is bothersome. So 1 over e to the third equals 6x minus 1. I'm going to proceed to solve for x. So if I just show you 1 over e cubed plus 1 equals 6x, you guys all know what I did, right? I want a common denominator here. So it's e to the third. So this is going to be 1 plus e to the third equals 6x. Divide by 6 on both sides. Okay, so divide by 6, divide by 6. So x is actually going to equal 1 plus e to the third over 6e to the third. Okay? So that's how you would solve that. Now, your variable x can be placed in wherever it wants, right? And it's your job to just figure out what x is. So we're going to solve for a positive value of x. So we're going to take the x, that's my base, take it to the second power, that's my Jane, equals 100. So now you got to think, if x squared equals 100, what is x equal to? X is equal to 10 because 10 squared is 100. if you did not know that, in order for me to cancel out a squared, you take the square root, right? The square root of 100 is 10. All right. The next one down here, this one is the easiest placement of x because 9 is my base, Jane is my 2, 2 is my Jane, equals x. 9 squared is just 81. Okay, x equals 81. All right. And that's it for this one here. Now I'm dealing with some fractions. So I know my log function is isolated, so I can use the Tarzan and Jane rule. X is my Tarzan. Gonna pick up Jane, which is -1/5. So -1/5 power equals 1/3. Okay. Now here, remember the rule, if a to the b to the c power, we multiply the powers, right? B times c, correct? We multiply the powers. So here, when it's x to the -1/5 power, I want to get that power to 1. And the only thing that I can make it equal to 1 is using this rule here of multiplication, right? Okay. So x to the 1/5 power. So if I have x to the -1/5 power, equals 1/3, I believe. I think I'm on the wrong slide here. Yeah. Equals 1/3. I'm gonna take this to the -5th power. Why I take it to the -5th power is because -1/5 times -5, that will equal x to the first power, right? 5/1. Those two guys become positive. Those two guys cancel out. You just have 1. So on my left-hand side, I will just have x equals 1/3 to the -5th power. Right now, we just got to deal with the negative, or 1/3 to the -5th power. Since that's a negative power, I'm going to take the reciprocal of the base, 3 to the 5th. So 3 times 3 again is 9. 3 times 3 again is 9. 9 times 9 is 81. So that's 3 to the 4th, right? So 81 times 3 is 243. Okay, so x is going to equal 243. Okay? All right. The next one here, my logarithmic function is isolated, so I can use the Tarzan and Jane rule. So x to the 1/2 power equals 3. I am going to take both sides and square it, because 1/2 times 2 is just 1. 3 squared is 9. Okay. All right. So this one is a little bit different. Yeah, it says to condense the logarithm. Okay, so we're gonna use those laws or those rules to make it into one. All right. So here, this first one, I see it's being multiplied by r, right? Log base a or log of a. So I want to take it and put it up there. So log a to the r power. Okay. And then I'm going to do the same with this 8. Put it up there. So that's minus log q of to the 8th power. Okay. And then the minus leads me to say division. So since we have the same log base, right? Log of 10 basically and log of 10, just log. We can use the rules. And the rules state when it's a subtraction, we can put it together with division. Oh, q to the 8th. Yeah. So that's my answer there. All right. So we're just using these rules to either expand or to condense. Okay, so it's this one too is a condense. Okay, so the first one here is log b of 7 to the 7th power plus log c to the q power. Now, since I have the same log base, just log, and we're adding the two, we can essentially just multiply the two. And that would be to condense it into one log function. Okay? That's that. This one, the previous two examples, we condensed it down into one, right? This one, you have one and you want to expand. Okay, so we're just going in opposite directions. The first rule that you want to implement is this 3 rule. Okay, so it's 3 times the log of 7x, right? Now, since 3 is being multiplied to log of 7x, whatever I expand from log 7x has to be multiplied to 3. All right, so I'm going to leave this 3 out here. I'm going to put brackets here. So when I expand this guy out, right, I know I'm going to be multiplying by 3. So it's going to be log 7 plus log x. Okay, that can be your answer, or this can be your answer as well. 3 log 7 plus 3 log x. Okay, just distributing this 3 out. All right. Cool. Next one here is to expand this out. Now notice here that this cubed, right, is only to the x. It's not to the y, right? So I have to use a division rule first, where it states, hey, if we're dividing something, right, and it's one log function, we can subtract the numerator by the denominator. Okay? And then since I have this 3 up here for the x cubed, I can bring that down here. So it's 3 log of x minus log y. That is my answer. Okay, that's how you would expand it out. All right. In this case, we are solving now for x. in terms of an equation like this. So the first thing you got to do is you have to condense this, my left-hand side of the equation, into one log function. Okay? So just like what we did in our previous examples, plus log 2 of 7 squared, right? I just moved this 2 up here in my exponent. Now, since this is plus, I can put it all under one log function and just multiply. 7 squared is 49 equals 3. Okay. Multiplying 4 and 5, or 49 and 5, that's 245x equals 3. Now that I have one log function, I condense it down into one log function. I am going to take this, Tarzan and Jane, this log function, so 2 to the third power equals 245x. 45x. 2 to the third power is 8 equals 245x. Divide by 245 to solve for x. So x is going to equal 8 over 245. That's your answer. Okay. Here is more or less the same, right? The left-hand side, I want to condense into 1. So log of 6 of 9x minus log 6 of 2 squared. Since that's minus, I can divide 9x over 4 equals 3. Now that I have one log function, I can take my base of 6 and Tarzan and Jane this. So 6 to the third, 6 to the third power equals 9x over 4. 6 to the third power is 6 times 6, 36. 36 times 6 is 216. Okay. So that's 216 equals 9x over 4. Multiply both sides by the reciprocal of 4 over 9 to solve for x. So x is going to equal 4 over 9 times 216. $96. That is your answer. Okay. Here, this one's pretty easy. So if you just set it equal to x, 9 to the x power equals 9 halves. 9 to the x power equals 9 to the 2 power. So x is going to equal 2. So we're good with that. This one, this is an exponential function, correct? If this is an exponential function, we have to turn it into a log function, making that equal to x. I just have to solve for x, right? So log base 9 equals log 9 of 9. So the reason why I did that, right? Blank, blank, blank. Know the Tarzan and Jane rule. This is my base, right? This 9 is my base. So I have this base. Log 9 of 9 is my Jane or my exponent, which is this exponent here, and it equals x, right? So that one has x. So if log base 9 of x equals log base 9 of 9, x has to equal 9, right? Okay, pretty simple. This one is more or less the same. All right, it's just a little bit more confusing because we have log base 6 of 6 plus log base 6 of 11. So if I use the form log blank of blank equals blank, log base 6 of log base 6 of 6 plus log 6 of 11 equals x, right? Okay. Now, since the left-hand side has one log base, right, I want to condense this into one log base. So this will just be log base 6 of 6 times 11, which is log base 6 of 66 equals log base 6 of x, bringing that down. So x must equal 66. Okay. Okay. Last one for today. Since this is already a log function, I'm going to make this equal to x. Get my base of 12 to the x power equals 1 over 12 square root of 12 cubed. Okay. I know I want a base of 12, right? This one here does not have a base of 12 yet. That one there, the circled one, does not have a base of 12 yet. To make it a base of 12, it's going to be the square root of 12 to the third power to the negative 1 power, right? Because I took the reciprocal of the base. Okay. Now, when I see the square root, what power is the square root? 1/2. Yeah, 1/2. Okay, so square root is 1/2. So I can rewrite the inside as 12 to the third to the 1/2 power, correct? But this is all also to the negative 1 power, right? So 3 times 1/2 times negative 1 equals, because you multiply the powers, equals negative 3 halves. That equals 12 to the x power. So x must equal negative 3 over 2. Okay? Simple-ish. Easy. Please, if you guys have any questions, come and see me. Or leave a comment. I'll try and get to them. That's the lesson for today. Thank you.